we now discuss the solution of a problem from the section Differential Calculus. The problem is about to count the number of discontinuities of a given function. This question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is, let f and g be functions from the set R to itself, where R is the set of all real numbers defined by f of x is equal to bracket x, where x is less than 0. F of x is equal to mod of 1 minus x when x greater than or equal to 0. And g of x is equal to e power x minus x when x is negative, x minus 1 whole square minus 1 when x greater than or equal to 0, where bracket x denote the greatest integer less than or equal to x. Then the function f compose g is discontinuous at exactly, we are given 4 options. Option A 1 point, option B 2 points, option C 3 points, option D 4 points. We are given two functions f and g defined from R into itself, where R is the set of real numbers. fx and gx is defined like this, where bracket x is the greatest integer function, that is bracket x denotes the greatest integer less than or equal to x. Then we have to consider f compose g, the composition of two functions f compose g, and we have to discuss the number of discontinuities of the function f compose g. We now discuss the solution of the problem in detail. We have f and g are functions from R into R, where R is the set of real numbers defined like this. Agreed. Then f compose g of x is equal to f of g of x, that is by definition for all x belongs to R, and required to find the number of discontinuities of f compose g, the composition of two functions f compose g. We have to consider and find out the number of discontinuities. Now first let us take g of x and how g of x behaves. So whether g of x is greater than or equal to 0, where, and g of x is less than 0, where. So first we take g of x is equal to the first branch of g of x. It has two branches, e power x minus x when x negative. Right. Now notice that g of x is always positive. Why? G of x is e power x minus x, and it is known that e power x is always greater than x for all x belongs to R. This can be seen if you draw the graph of e power x and the graph of y is equal to x. You will see y is equal to x lies below the graph of y is equal to e power x. So that will tell you e power x is greater than x for all x belongs to R. Therefore, e power x minus x will be greater than 0 for all x belongs to R. Therefore, g of x is greater than 0 for all x belongs to R. So, therefore, g of x is greater than 0 when x less than 0. It is true for all x belongs to R. So, it is also true for all those x when x negative, x is negative. So, gx is positive when x is negative. When gx is positive, f of g of x is positive, so it will go into this one. So, f of g of x is equal to f compose g of x is equal to f of g of x. What is g of x? G of x is greater than 0. So when it is greater than 0, it will go in this, and that will be 1 minus g of x. 1 minus g of x. What is g of x? E power x minus x. So it is mod of 1 minus in brackets e power x minus x, that is 1 plus x minus e power x when x is negative. So what are we doing? We are trying to find out what is this function f compose g. F compose g function we want to find, and f compose g we have found when x is negative. Second, now we consider g of x is equal to the second branch of g of x, namely x minus 1 whole square minus 1 when x greater than or equal to 0. Agreed. You notice that g of x is equal to 0 will imply x minus 1 whole square minus 1 is equal to 0. Simplify, you will get x is equal to 0, comma 2. X is equal to 0 and x is equal to 2. So, what is this g of x? G of x is a curve, continuous curve, x greater than or equal to 0. It crosses the x-axis at x is equal to 0 and x is equal to 2. So, g of 0 is 0. So, we go to f compose g at 0 is equal to f of g at 0, that is f of at 0. So, f of at 0 is, you go the second branch of f, so you substitute x is equal to 0 here, it will be 1. It will be 1. We continue in the next slide. So, this is what we have done so far. And we have already seen g of x is equal to x minus 1 whole square minus 1 when x greater than or equal to 0. And g of 0, g of 2 is equal to 0. And f compose g of 0 is 1. These are the things what we have already seen. Now, so what is g of x? G of x is x minus 1 whole square minus 1. So, it represents a parabola. It represents a parabola opening upwards and crossing x-axis at x is equal to 0 and x is equal to 2. So, it will be like this. So, a portion of the parabola between 0 to 2 will lie below the x-axis. So, that will tell you g of x is negative in 0 less than x less than 2. So, g of x is negative when 0 less than x less than 2, and when x greater than or equal to 2, when x greater than or equal to 2, it is greater than or equal to 0. So, greater than or equal to 0. So, now we got the behavior of g of x here, and now f compose g of x will be equal to f of g of x. Now, let us get into the first one. When 0 less than x less than 2, g of x is negative. So, when it is negative, the definition of f is bracket x, that is bracket g of x. And when x greater than 2, it is greater than or equal to 0. When x greater than, when g of x greater than or equal to 0, then fx will be mod of 1 minus g of x. 1 minus g of x when x greater than or equal to 2. So, now let us see, let us further simplify. G of x is what? In the second case, g of x is x minus 1 whole square minus 1. So, bracket x minus 1 whole square minus 1 when 0 less than x less than 2. And in the second branch, mod of 1 minus g of x. G of x is x minus 1 whole square minus 1 when x greater than or equal to 2. Simplify further. The first branch is as it is when 0 less than x less than 2, and when you simplify it is minus minus plus, that is 2 minus modulus of 2 minus x minus 1 whole square when x greater than or equal to 2. So, thus f compose g is completely known to us. So, let us see what the f compose g is. F compose g of x, when x less than 0, it is modulus of 1 plus x minus e power x. When x is 0, f compose g is 1. Between 0 to 2, it is bracket x minus 1 whole square minus 1. And when x greater than or equal to 2, it is modulus of 2 minus x minus 1 whole square. Is it clear? Yes. That means f compose g is a function from R to R which is completely defined like this. Now we are ready, to see the discontinuities of the function f compose g. So we have f compose g is this piecewise function. So now see, look at the f compose g. So the components of this function are 1 plus x is polynomial which is continuous everywhere, e power x which is continuous everywhere. So the modulus of a continuous function is again continuous. So this is continuous. One constant function is continuous. This is a polynomial, continuous, and bracket of that only 0 less than x less than 2. 0 less than x less than 2. And it is the value at the end point 0 and 2, it is 1 only. It is 1 only. It's not varying much. So this is a bracket of this is also polynomial, and everything is continuous. This is all continuous function. One may get about the bracket function here, and between 0 to 2 it is at the end points it is 1, and in between it is negative. Anyway, so it is continuous everywhere except possibly at x is equal to 0 and 2. So 0 and 2 are the points, where these branches of the curve are connecting. So the connecting points are 0 to 2. There the continuity is to be discussed, right? So let us get into. Observe that limit extends to 0 plus of f compose g of x. So when x is 0 plus, substitute for x 0 plus h. So 0 plus h. So x tends to 0 plus means what? X tends to 0 plus means in this branch. Go there, bracket of for x 0 plus h minus 1 whole square minus 1. So in this branch you go. And now look at in the inside h minus 1 whole square minus 1. Now h is close to 0. H is positive, close to 0. H minus 1 is less than 1. It's a square. It's less than 1. It's a square. H is close to 0. H minus 1 square is positive less than 1. So that means if you subtract minus 1 throughout, so if you subtract 1 throughout, 0 minus 1 is less than h minus 1 whole square minus 1 is less than 0. So that means h minus 1 whole square minus 1 will lie between minus 1 and 0. So therefore the bracket of that is minus 1. Agreed? It's clear. So, but whereas f compose g of x is discontinuous at x is equal to 0. Why? Because limit extends to 0 plus of f compose g of x, that is the right hand limit at 0 is minus 1, whereas f compose g at 0 is 1. So if at all it is continuous, these two values must be equal. It is not. Therefore, it is discontinuous at x is equal to 0. So let's get into limit extends to 2. Limit extends to 2 minus. Get into this branch. Extending to 2 minus. That means this branch. So that means write for x 2 minus h. Limit extends to 0. 2 minus h minus 1 whole square minus 1 bracket of that. Now 2 minus h minus 1 whole square will be 1 minus h whole square will be h minus 1 whole square minus 1. So this is bracket of h minus 1 whole square minus 1. It is same as the above. As h tends to 0, the answer is minus 1, because 0 is less than h minus 1 whole square is less than 1. Agreed. Limit x tends to 2 plus of f compose g of x, and that will be equal to limit x tends to 2. 2 plus means here 2 plus means here. Bracket of 2 minus x minus 1 whole square. Limit extends to 2 because it is continuous. Therefore, we can take it like this. And when limit is taken, is because it's a continuous function, simply replace x by 2. You will get the answer is 1. The answer is 1. So they are not equal. Observe that they are not equal. The f composed g of x is discontinuous at x is equal to 2 because the right limit is not equal to the left limit. One is 1 and the other is minus 1. So they are not equal. Therefore, it's not continuous. It is discontinuous at x is equal to 2, and it is also discontinuous at x is equal to 0. So the f composed g of x is discontinuous at x is equal to 2. Let us summarize now. Thus, f composed g of x is discontinuous at x is equal to 0 and x is equal to 2. Therefore, the function and at the remaining points, the f composed g was continuous because it is involving all continuous functions. Agreed. The function f composed g is discontinuous at exactly 2 points. So let's look at our options. And our answer, it is discontinuous at exactly 2 points, is precisely at the option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of a problem from the section Differential Calculus, wherein you are asked to find the number of discontinuities of the given function. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.